Okay, so this is for our first example. This video is going to be for the TI-84 calculator. If you have an Inspire, there's a handful of y'all that do. It's a similar process that y'all have been using before. You push, believe the menu button, go down to tests if you're doing a test, or a confidence interval if you're doing a confidence interval. That being said, okay, so once again, if you are for the Google Sheets video, I'll have that labeled in a different spot. So please go ahead and click on that one now and move out of this one. Okay, so today's example, our first example, what I'm going to be looking for here is what kind of test am I doing. I want to find my 6 steps for a hypothesis test. We want to be finding our null and alternative hypothesis, our alpha, all those 6 steps. If you don't have those, I would review them and write it in your notes, or at least go look for those and make sure you have them in front of you before we begin. Okay, in a nursing home study mentioned in Chapter 1 opening statistics today, the researchers found that 12 of 34 randomly selected small nursing homes had a vaccination rate of less than 80%, while 17 of the 24 randomly selected large nursing homes had a vaccination rate of less than 80%. With an alpha of 0.05, test the claim that there is no difference between small and large nursing homes with vaccination rates of less than 80%. All right, so what we're going to do first is we're going to take this problem, and I'm actually going to do a confidence interval with it first, just to show you how to do that. Fortunately, this is not very difficult. So what we're going to do is we're going to go to statistics. We're going to go to our confidence interval. So it's under the tests tab. And we go down to confidence interval. And now what kind is it? Well, it's a proportion because we're saying 12 out of 34. And 17 out of 24. That's my clue for being a proportion. This 80% actually has nothing to do with whether we're doing a percentage or not. Okay, so I scroll down and look for a proportion to proportion interval. There it is, letter B for me. X1, N1, X2, N2. Now, what I really recommend y'all do on these problems, because they can get kind of wordy, if you can underline, highlight, or at least when you're reading it, write down, this one, X1 is going to be for the small nursing homes. X2 is going to be for the large nursing homes. Just so you don't lose track of variables, because while this one is very straightforward, problems in the future are going to have a lot of information, and you want to make sure you're labeling everything appropriately. So make sure you do that. Okay, so I'm just going to pull it off screen here and just type it in. So we have 12 is my first X. My sample size for small nursing homes is 34. My sample size, my X for large nursing homes is 17. My sample size is 24 for the large nursing homes. And then if my alpha is 0.05, the confidence level is going to be 0.95. And we go ahead and just so you see the screen right here, 0.95. All the information appropriately in the right spot, and we calculate. And there's my confidence interval right there. Now, what this is saying is the average difference between the two is, okay, I'll say this slowly. This is how we interpret it. This is how you must say it in your homework. I will not give you credit if you do not say it like this. I'm very particular about this. We are 95% confident that the difference between the vaccination rate between small and large nursing homes is between 0.5. No, well, we can do a pause. Let's go 0.11 and 0.598. Or if you want to do it in a percentage form, you could say 11.3% and 59.8%. Your choice. It doesn't matter. Now, typically, what you want to do when you're typing in the calculator so you don't get these negatives, you want to put the larger proportion in your P1, in your X1 and N1, and your smaller proportion in N2. And what I'll do is always give you those positive percentages, so it's not so confusing. But that's it for confidence intervals. Pretty straightforward. It's not too terrible. All right. Now let's go and do our test. So same idea. Our null hypothesis here would be that, actually I'm going to type on here. Our null hypothesis would be that P1 equals P2. Our alternative hypothesis in this case would be that P1 does not equal 2. I don't know where my not equal to sign is, so we're just going to say not equal to P2. Because what does it say here in the last line? Test the claim that there is no difference. And if there is no difference, we're saying not equal to as our alternative hypothesis in this case. Just a reminder, null is always equal to. Alternative is going to be what we're trying to test the claim of. Alright, that being said, my alpha is 0.05. We know we're doing a 2 proportion test. So let's go ahead and I'm going to go ahead and delete this. Oops, too much. Okay, so I go to tests, statistics, tests, 2 proportion test. That's number 6 right here. Number 6. And then you'll notice all my information is actually here already, which is kind of convenient. So, and we know we're doing a not equal to test, and then we calculate, and here's my information already done. Here's my test, here's my critical value. Sorry, my test statistic. Here's my p-value. This is if you were to actually, p hat 1, that's if you were to actually divide 12 divided by 34. P hat 2 is if you were to actually divide 17 out of 24. So those are not very useful values. I mean, we can use them, but I don't think it's necessary. Don't worry about this value. It's technically, if it's pulled together, if you want to know about that value, what that means, we can discuss at a later time. So what we do, we compare p-value to alpha. Here's our p-value, 0.007. Well, we'll say 0.008 for rounding. So what we would say here is, well, my alpha is 0.05. So let's go ahead and type our interpretation then. Since the p-value of 0.008 is less than an alpha of 0.05, we reject the null hypothesis. There is sufficient, that's bad spelling, statistical evidence to suggest that there is a difference in vaccination rates between large and small nursing homes. How do you fix that? All right, so, well, what does this mean then? What does it mean to you? I think is a better question. Because what this means to me is that if I have the opportunity to put my grandmother in I have to put my grandmother in a nursing home or my own mother in a nursing home, I may not want to choose a small nursing home. I may want to choose a large nursing home because they have better vaccination rates. And that's what it means to me personally. That's the kind of decisions I want you to be thinking about. Yes, we have to know the statistics. That's the math behind it. But what does it mean for you? That's what's really important here. Okay, check my timer. Okay, so I'm going to have to create another video for the next 2 examples because I've just simply run out of time.